Hi, my name is Shaun Wallace. I'm a PhD candidate at Brown University. My work focuses on extending the maturity phase of evolving data. Not all data is static. To maintain its accuracy as it grows in size and evolves, it's necessary for groups of people to collectively review and edit data. One of the forms I focus on in my work is computer science professors. Now, this data changes naturally over time due to new hires or people changing their research areas or universities. When I develop these systems, I ask how they can adapt with the evolving information to empower human collaboration. What I found is that you can create a mutually beneficial relationship between the users and the accurate information they seek. This is often wrought with errors, so you have to develop reward mechanisms to motivate users to continuously contribute new information. During my PhD, I've developed 3 of these systems: Drafty, Sketchy, and the Virtual Readability Lab. Today's talk will focus on Drafty. Now, Drafty started as a spreadsheet of computer science professors that we crowdsourced. And while our initial efforts proved successful, we found it was difficult to maintain and check all of the users' proposed edits over time. Human errors are common. Even if somebody makes a typo, there's an error, might not have been intentional. This requires constant upkeep. So we went with this idea that maybe we'll build our own system and hopefully users will visit it. This is the initial version of the system, which allowed people to freely make edits, similar to Google Sheets. But most importantly, the system would ask people to fix data that matched their interests. We found that people submitting edits for data they were interested in were 3 times more likely to submit accurate data. What about the traditional use case of paying crowd workers? Well, we ran 2 naturalistic studies, one with paid crowd workers that lasted over 14 days, and then we continued running Drafty for 2.5 years. We found that across all strategies, editing a professor's subfield area of expertise had the lowest accuracy per data type. Now, subfield area of expertise requires domain-specific knowledge. Many paid crowd workers often thought a computer science professor's area of expertise was computer education, where it might be databases or human-computer interaction. And we found over this 2.5-year longitudinal study, users, when they were asked to fix data, were accurate 95% of the time. But when the system asked users to fix data matching their interest, they rejected the request over 90% of the time. And this is something we found not only in Drafty, but in other systems, was the idea that users should be able to initiate these requests themselves and not the system. Users who visited Drafty had an interest in the data, and this led to them providing domain-specific knowledge to create accurate edits for subfield area of expertise. Now, a quick summary of these 2 case studies. One thing we did find that within the unpaid maintenance strategies is we did not detect any vandalism, and also that the number of edits or visits did not correlate with accuracy. So therefore, we could actually rely on, multiple users making 1 or 2 edits. We did not need, 3 users making the bulk of edits to maintain this data set. I hope to continue this line of research, both expanding Drafty and the other systems to empower human collaboration. Thank you.